Okay, hello. Okay, welcome back to the class after midterm. Okay, today we will talk about the protocol, Modbus protocol. Okay, which is the protocol that widely used in many applications, especially is used in the industry. Okay, that connect to the PLC. Okay, so that's why we have to learn the Modbus protocol. Okay, because before we go to the HMI, okay, which is the touch screen, okay, to control the system, to control the automation part, okay, not only PLC, okay, that can run for all, yes, you can run for all, but you need the monitor, you need the uh, input interaction, okay, human interaction, okay, for the system. Okay, so in order not to waste the time, let's go to the Modbus protocol. That we will use this protocol for connect HMI, okay, together with the PLC. So PLC can transfer the data, okay, even the coil control, okay, to like monitor, to show the status, okay, in the HMI. Okay, you can use this for the monitoring, or you can use this for control, or you can add the number or whatever, because HMI, okay, is a human interface, so you can write the skin, or you can decide whatever you want, and you have to connect with the coil, okay, with this coil and the data inside of the PLC, so you can capture, okay, that coil is the status, you can capture the data from PLC to show it out, okay, or you can just monitoring number counter or whatever, okay, in the PLC, and you can show it to HMI. You just configure the coil, okay, you just configure the coil. Okay, let's see, this is a structure, okay, and wiring structure that, okay, we will uh, use, okay, in the lab. Okay, basically it's already connect for you, but I will tell you again, it's like, okay, basically we have only this is like a controller, okay, normal controller PLC just have input and output, okay, input and output. But if you would like to communication with another way, with like not IO, input and output, but you need like the protocol, okay, you need the protocol in many physical style. In this case is the physical style of this is RS232, okay, RS232, basically it have RS232, RS485, okay, something like this is the structure and the wiring and the module of this, okay. With this, okay, we use the module RS232, okay, with the RS232 port, okay. And when you use the RS232 port, like here you connect with this, okay, you connect by using this, and it have the plug here, okay, you can connect it. After you connect it, okay, if you add another one module, okay, this module, okay, so you can use Modbus protocol, okay. Modbus protocol based on the physical office is RS232, okay. And you got this connect, okay, and you also have the HMI, okay, HMI touch screen, okay, like here. And this is the part that you can connect it together, okay, you can connect it together by using RS232 physical style. And okay, this is a part inside, you have TX connect to RX, you have RX connect to TX, right here, and ground to the ground, like this, okay. So in this case you can connect together, via female jack and male jack, connect like this, okay. This is how to connect this, and how do you have to find the module in order to connect to the skin, HMI skin. Okay, we use RS2T2 because of the component of the touchscreen is support RS2T2, so that's why, okay. Okay, this is wiring diagram, okay, for the drawing part, okay, we're just showing that, okay, you have the control board connect based on the Y RS232, okay, like here. So you can capture every data, even coil, even the number of color inside, okay, to show at this, but you have to map it. Okay, you have to map. Okay, maybe you decide this bottom, okay, to click on and off maybe. Okay, you can map with the coil inside of the PLC. Okay, it's maybe coil M1000 maybe. And this is a coil of this, and then you connect this with this. Okay, when you turn on this, okay, this coil will change the state to be 1 or something like that. Or you have the data something inside but collect like 300 something, okay, and then you would like to show at this, okay, so you connect with the D100 something, okay, and then you capture the detail inside and show at this position. Okay, like here, this is how does the HMI work to connect to the PLC. Okay, let a little bit deeply in Modbus protocol. Okay, what is the Modbus protocol? Modbus protocol is a data communication protocol originally published by Schneider Electric, okay, since 1979. So it's used like start from long times ago. Okay, for use with what? For use with PLC, programmable logic controllers. Modbus is popular and widely used in industrial environment because it's openly published, okay, and is development for the industrial application, okay, and is easy to deploy maintenance compared with another standard, okay, like this. Okay, this is why that, okay, Modbus protocol is widely used in industry, okay, and you have to learn it, okay, because it's widely used in this. Okay, and Modbus protocol use character serial communication line, okay, or Ethernet protocol. Okay, so it have many style. Okay, today we will teach you two style, okay, of the Modbus protocol. Okay, so okay, this is the detail of this. Okay, it can use in for the one device or for multiple device at the same time. Okay, so you can use Modbus protocol to get the data of this. Maybe you have the module, okay, you have the module, maybe module temperature, module humidity sensor, something like that. Okay, it will connect to the computer or connect to the PLC, and then you would like to show it, you would like to capture it. Okay, so you can use the Modbus protocol. Okay, and Modbus is basically is used to connect with the plant and system. Okay, and with one thing, okay, we call remote terminal unit or RTU. Okay, this is a easy one. Okay, easy one of the Modbus protocol. Okay, Modbus protocol basically have two style. Modbus RTU, okay, which is remote terminal unit, okay, and Modbus TCP, okay, Modbus TCP IP, okay, but use LAN, okay, to connecting it. Okay, but in case of the Modbus RTU, so you can use RS232, RS422, RS485, okay, something like that. Okay, let's see. Okay, as I told you, it have two types, okay, of the Modbus. Modbus RTU, okay, Modbus RTU, okay, and Modbus TCP, okay, Modbus RTU and Modbus TCP. Modbus RTU, remote terminal unit, okay, and it's used in different application. Okay, if you would like to send the data, okay, to very long, okay, very long, okay, so you can use Modbus RTU. Okay, the maximum range of this that you can send the data to is around 1.2 kilometers. Okay, but speed of this just 57.6 kilobyte, okay, kilobit per second, sorry, okay, kilobit per second. But if you use the Modbus TCP, okay, which is run by LAN, okay, like a LAN connection, LAN WAN, okay, LAN WAN, something like that. But in this, okay, you can run it's like for like 100 megabit per second, okay, 100 megabit per second, but just only 100 meter. Okay, so one pass, okay, send very long, but speed up is very slow. And some part, oh, run very fast, or run very fast, and you can transfer the data very big, okay, but in the short length, okay, something like this, okay. Okay, and the Modbus is like a master slave, okay, it's like a master slave. So you have to have the master and you have to have the slave. Okay, master have to request first, okay, request for the first one, and first one respond, request for the second one, the second one respond, request to the third one is respond, something like this. Is a master slave style, okay. Okay. Like here, and this first one is Modbus RTU. Okay, this is a Modbus RTU. Okay, so it's like a series. Okay, it's like a series. Okay, series of this. And another one is Modbus TCP. Okay, Modbus TCP is used in many applications as well because it's very fast. Okay, so if you would like to transfer the data to show very fast and the data is very big, okay, so we have to use TCP. Okay, and it's have the Modbus client, okay, with the computer HMI. Okay, and you have the bus. Okay, it's operated and run by Ethernet. Okay, it's operated and run by Ethernet. Okay, and use internet like a bot. Okay, internet like a bot. Okay, and you can have like, okay, PLC. Okay, you can have the PLC, okay, in the branch. And this is like a Modbus server, and this is a Modbus client. Modbus server send the data, okay, send the data to HMI, okay, read and respond the data to this. Okay, so in this case, okay, so you can also use the gateway as well if you have the Modbus RTU. Okay, if you have the Modbus RTU, you have to have the gateway to transform, okay, serial port to be, okay, the Ethernet, okay, based on like LAN communication, something like that. Okay, but in case of TCP, you see, okay, you can connect freely. Okay, you can connect like freedom. Okay, you connect easy. Okay, but run by Ethernet, and the speed of this is very fast. Okay, it's very fast. Okay, and this is the Modbus RTU. Okay, you connect like a CD like this. Okay, so it's like, okay, it's slow, but it's can send for like long length. Okay, like that. Okay, let's see the thing that more deeply in RTU. Okay, I will, okay, highlight on RTU because in the lab, okay, we use the Modbus RTU. Okay, so Modbus RTU is a serial based protocol. Okay, serial based protocol with architecture master slave communication. Slave will respond if master sorry, okay, sorry, slave will be respond if master request. not don't request. Okay, slave will respond if master request. Okay, something like that. And this is the package of the data, okay, in the Modbus protocol. Basically it have six part. Okay, have 6 part in one protocol. Okay, you remember last time is maybe have like the POW like this. Okay, POW something like this. It's the size the same. When it's communicates, you communicate like a POW. Okay, communicate like a POW is a bit. Okay, communicate like a bit. Okay, but it have the part of this. It have the part of this. Okay, first part is start. Another one is end. Okay, in order to start the protocol, okay, to tell the client that, okay, this is start part of the protocol and this is the end part of the protocol. But it's the main thing, okay, is 4 types of this, which is address, okay, which is function code, which is the data, and which is the CRC or cyclic redundancy check. Okay, like a check area. Okay, you send the word, okay, maybe forward to the output. Okay, the output have to check it. Okay, is correct or not, or the data that you send, okay, when you submission it, and it show in another word. So that means, okay, it maybe have loss, okay, when you, okay, transfer the data, something like that. So that means when you send the data, you have to pack this code, okay, and pack the summation of this code together. And after it capture getting this, okay, if you check the summation of this word, and then okay, transform to check the word. Oh, it's if the summation of this and the word same, okay, so that means it's no lost communication, something like that. So that means you can capture the data and then use, okay, something like that. Okay, and length of bits for the address is 8-bit function, 8-bit data n multiply 8, CRC 16-bit. Okay, okay, address is station address. Function is a function to read, to write, the coin, the register, or whatever is have the code of this. Okay, and also data that you would like to transfer. It's just a bit, or it's just the maybe the number. Okay, whatever, it depends on you. Okay, the physical layer of the Modbus can use RS 232, RS 485, RS 422. Okay, like here. And data will store in 4 types. Okay, like this. Okay, so store data. Okay, in part of the data can store 4 types. Okay, can store 4 types. Can store like a output coin. Okay, like a bit. Input contact. Okay, input register 16-bit. Holding register. Okay, 16-bit. Okay, so that means data can be 4 types. Okay, so that means it depends on you when you control it and you force it or command it. Okay, this is a function code. Okay, function code. If you like just only delete, okay, you use 0, 1, right single, right multiple, or any other. Okay, this is a code index. Okay, index is decimal. Okay, in decimal, sorry. Okay, so you can use this, okay, in the code, function code. So that means when the slave can read it, okay, if you send the thing that the master requests, okay, like that. And this is an example, example case for the Modbus RTU, how it operates. Okay, to do what? To do to read holding register at address 4012 103. Okay, 2 40125. Okay, so which is 3 data. Okay, from the address, this is okay, you can see 3, 4, and 5. Okay, 3, 4, and 5. Read the holding register. Okay, read the data inside holding register. How many part? How many address? 1, 2, and 3. 3, 4, and 5. Okay, 3, 4, and 5. Okay, so that means read 5 data from holding register. Okay, okay, read from what? From the slave device number is have the address, right? Okay, slave device number 19. Okay, let's see the frame of the message. Okay, the message frame. Okay, except start and end bit. Okay, so if you send like this is the data that's sent from the master. 13 03 0066 003 E6 A6. Okay, whatever. What is this? Okay, and when you send this to the slave send the data back like this. Okay, let's see the meaning of each one. Message from master. Okay, this is a message from the master. It's like a request from the master. 13 is station address. Okay, 13 is station address. Okay, so number of the ID is 19. Basically, when the system operate and talk together, okay, they use hex or binary. Okay, but in this case they use hex. Okay, so address or ID number 19 equal 13 in hex. Okay, 13 in hex. Okay, so that's why this is 13. Okay, you see the structure of this unit ID that you want. Okay, you send unit ID that you want. It will go to this. It's not go to another. It's basically it's go to another, but it's not correct. So that means this will just only one that return. Okay, only one that response. Okay, something like that. Okay, so the next one 03. Okay, 03 is a function code. Read what? 03. Okay, read holding register, because now we need to read holding register. Okay, so they use 03. Okay, next is 0066. What is 0066? Address of the first register. Okay, address of the first register. Okay, address of the first register. Okay, basically it should start at here, 4001. Okay, this is the start point that store, okay, in the holding register. Okay, so address that you want is here, right? Address that you want. Okay, maybe you can imagine that, okay, it start by 1, right? But this collect at 103. Okay, so that means this is the address of the first register. So that means, okay, you use the first data that you want to capture, okay, minus the first part of the register, that is half. Okay, so they've got 102 in decimal. Okay, 102 in decimal, and then you can transfer it to be hexadecimal, which is 66. Okay, which is 66. So that's why this is 006, because when you use 006, so that means you use plus from the first one. Okay, and then start this address, okay, to capture the first address, something like that. Okay, this part is data. Okay, this part is the data. Okay, and then 003. Okay, this also data as well. 003, number of the register required. Okay, number of the register required. How many? 103, 104, 105. So that means 3 data. Okay, so that means we need 3 data. Okay, from the address this. Okay, from this address, and then 104, 105. Okay, to capture. Okay, and then this is the CRC code. Okay, this is a CRC code to check cyclic, okay, redundancy check. Okay, to check like, okay, the summation of all, okay, summation all of this. Okay, and when you, okay, check it, okay, you check this, and then check the summation of this. Okay, so it should be the same. Okay, it should be the same. If it's not same, so that means it have lost some value. Okay, it have lost some value. Okay, like that. Okay, this is the data that's sent, okay, from master to slave. Okay, so master to slave, and then slave, okay, can capture the first one. Okay, talk to me. And what they need, okay, they need what? They need the reading the holding register. Okay, pack the holding register. Which the address? Okay, you capture the address number 103, 104, 105. Okay, and okay, check sum, check all, whatever. And after that is the return. Return what? Okay, let's see the return part. Return what? It was 06 and x and x. The 06 is number of response in byte. Okay, number of response in byte, 6 byte, something like that. And x is the 3 response data. Okay, 3 response data. Okay, like this. It will return. So that means, let's see how the master communicate with the slave. Okay, like this. Okay, this is how does Modbus+RTU work. Okay, Modbus+RTU work. Okay, and another one is Modbus+TCP. Okay, we not highlight on this, but it's using a lot as well. Okay, but Modbus+TCP is has a structure like this. Okay, it's like extended, okay, from the Modbus+RTU. Okay, which is Ethernet-based protocol. Okay, with TCP/IP. Okay, physical layer, and it's mainly operated by local area network or LAN. Okay, or internet network. Okay, like this. Ethernet network or LAN connecting this, and it will have another one. It will have let's see, this is a Modbus+TCP, okay, protocol, and this is the Modbus+RTU protocol. Modbus+RTU need only 4 of this, and Modbus+TCP have the structure of this, have the section, okay, transaction ID, protocol ID, length, and then you need ID, function code, and data again without CRC. Okay, this is a package of this. Okay, is what is the first one? Okay, this is a transaction ID, okay, used by the master for matching the response message from the slave. Okay, and protocol ID indicate the protocol of the protocol data unit. Okay, like that. Okay, this is a protocol ID. Okay, message link, okay, message link to store the message site, okay, and module ID, okay, module ID or unit ID, okay, like Modbus RTU, okay, used for specify this the slave connected, okay, which the slave that you want, okay, something like that, and function code and also data, okay, that okay connect like this. So the packet of this is bigger, okay, so packet of this is bigger, so but it's run by lane, so that means the maximum speed of is around like 100 megahertz megabit per second, something like that. Okay, this is structure of Modbus TCP that different from the Modbus RTU. Okay, this picture can show you that, okay, how different between two of this protocol. Okay, this is like the data that transfer, okay, this one, okay, from what, from this transaction ID, okay, transaction ID, protocol range, okay, unit ID, function code, and data, okay, something like this, and then return, okay, and then return or response. Okay, this is for the part of the TCP IP, TCP, for the Modbus, okay, which is Modbus RTU, which is Modbus TCP, okay, like this. Okay,